This is the Kensington Adding Machine from 1993. It's a software adding machine for the Macintosh. I think we've all been there. You got some really hard math problem to do, and obviously you want to use one of these, but all you have is one of those stupid electronic computers. Well, have I got a product for you? 1993 was a weird time in the history of computing. The personal computer had existed for about a decade, but it wasn't exactly commonplace yet. People more or less knew that computing was about to change everything, but it just hadn't really hit yet. Computers were super expensive and not obviously better than whatever else people were using. And accountants or whatever, they were using electric printing calculator adding machines. I have this TI 5032 SVC. The main purpose is to add a big list of numbers and to make a printout where you can see the whole list and the total. Surely this we can do better with a computer, right? This thing really was obviously a good idea. The computer spreadsheet. You really can add a big list of numbers and get a total at the bottom, but check this out. What if you messed up one of the numbers? You just change it up here and the total updates automatically. This thing don't do that. But some people were not convinced because they liked the old machine. And you think a spreadsheet can really do everything better? Okay, well, can it print out the numbers one at a time as I type them? Can it print on this cute little tape that I can easily tear off and staple to my other papers? Can I use it with one hand without really looking as I type the numbers? We all know how this thing goes. Some people will embrace the new and better thing, and some people just won't. And the Kensington company saw an opportunity here. Their main business was hardware input devices. They're still in the game now, and in the 90s they were making keyboards and mouses, mostly for Apple computers. I remember when I was a kid, I saw the Kensington Track Ball, which I thought was super cool until I tried to use it. Anyway, one of Kensington's products was a numerical keypad, the Kensington Notebook Keypad. It was sold as an accessory to the PowerBook, which didn't have a built-in numpad. Only $129. But Kensington had a little something else to sweeten the deal. This is the Notebook Keypad Adding Machine version. This thing was the pack-in software to help sell the numpads, and I guess it was popular enough that they sold a standalone version, and that's what I have. I have the original big box, which was common for software in the 90s. The disc itself is real small, but they pack it in this giant, mostly empty box. Gotta get your money's worth. I do, of course, have the original floppy disk. This is a 1.4 megabyte high-density disk, but the program itself only takes up 156 kilobytes. Actually, somehow I ended up with two of them. I don't know what to tell you. I also have the original 88-page instructions manual. Check the links down there for a scan. Unfortunately, I don't have a 90s era Mac to run this on. I do somehow have an original Power Computing Power Center 132 Mac clone computer. No screen though, so I'm running this on an emulator. It looks like a normal calculator, but it's really not. The plus and the equal buttons, they're the ones you're going to use the most. They're actually the same button, plus equals. But there's also just a plus. And what's the difference? Well, the instructions manual, page 32, says, you can also use the plus equal key to perform the same operations as the plus key. Huh? This is actually true. The two buttons do exactly the same thing. Anyway, if I want to add like 5 plus 6 plus 7, I hit 5 plus equal. Oh yeah, it plays sounds. Back then, the Mac's built-in sound capabilities were pretty amazing. To a modern sensibility, you're going to want to turn the sounds off immediately. But back then, people would have loved it, at least for a little while. Anyway, to do 5 plus 6 plus 7, I go 5 plus equal, 6 plus equal, 7 plus equal. And it prints each one on the tape, and the little readout says the total, which is 18. If you want to print the total onto the tape, don't hit the plus equal again, because that'll just repeat your previous addition. You got to hit the total button, which is here, C-E-T. Yeah, the clear button is the same thing as the total button. I don't know. This is all pretty weird to me, especially the plus equal and the totaling. I find it completely unintuitive, but it comes from the long history of the printing adding machine. This basic device started off as one of these, and this doesn't have an equals button. You just keep on adding by pulling the crank, and then you have a total button to make the total. On this TI, it's labeled plus, but really this is like the crank on an old machine. And then you also have the total button to print the total. The TI machine also has an equal button, but again, it doesn't really do what you would expect. Look at this, 5 plus 6 equals, and nothing happens. The equal doesn't do what you think. But if you want to print the total, you hit total. All right. And there are multiplication and division buttons on there, but they work in a much more normal way. Like to do 5 plus 6, I go 5 plus 6 plus total. But to multiply 5 times 6, I go 5 times 6 equals. This is a weirdly inconsistent interface, but again, it's because of the history of the instrument. This kind of mechanical calculator just can't do multiplication and division. There were other types of machines that can, but they were part of an entirely different mechanical lineage. Anyway, these things never did multiplication. It was just a fundamental limitation of the design. But once they transitioned to electronics, it was easy to just add on a multiplication button. And this was always an extra sort of bonus feature. The multiplication interface was never really integrated into the basic printing and adding function. They're like two separate things, and you don't really expect them to work nicely together. And the Kensington Adding Machine has the same weird behavior. Look at 1 plus 2 times 3. A super simple calculator will evaluate this as I go left to right and get 9 as the answer. A more like scientific calculator would do the standard order of operations and get 7 as the answer. And the Kensington Adding Machine just doesn't want to mix the operations at all. 1 plus 2 times 3, nothing. Maybe 1 plus 2 times 3 plus equal, it's 6. Right? You're just not supposed to be doing stuff like this. To me, this is totally unintuitive, but this was actually the standard behavior that the people would have been used to. We're trying to copy this old machine, weirdness and all. The interface on the whole is a fairly extreme version of what designers call Skeuomorphism. That's when a new technology is designed so that it looks like the old technology, even though there's no real good reason it should look like that. It's like electric lights that kind of look like candles. They don't need to look like that, but whatever. Like here's the paper tape, which is meant to look and behave exactly like adding machine tape. You got the jaggy edge on top. There's even a button to advance the paper. And you click this sharp, jaggy thing at the bottom to rip it off. Don't cut yourself there. There's two main batches of settings here, which are pretty interesting. And they copy standard switches from accounting machines. This one controls how many decimal digits to show. The default setting is the plus. This makes it so that the decimal point always sits 2 positions over. That means if you type 12, you actually get 0.12, like 12 cents. This is how the old machines work. If you actually want 12, like 12.00, you got to type 1200. The F mode is what I was using before. This is the floating point setting where the decimal point just goes wherever it needs to go. This is how normal calculators work today. The other settings, 3, 2, 1, 0, give you fixed precision. So the 3 means the total always shows 3 decimal digits past the decimal point. 2 gives you 2 digits, you get the idea. This is kind of like in Excel when you can choose how many digits you want to see. But here it's not just about the display. The numbers get permanently rounded in each step. Like on 0-digit mode, it'll show only whole numbers. So when I go 3 divided by 2, it says 2. And this 2 really means 2 now. If I multiply by 2 here, I get 4. All these decimal digit settings will round the number every time. And these other settings control how the rounding works. This weird like 5/4 thing is the default. This is like normal rounding. That's not a fraction 5/4. It's more like a cutoff line between the 5 and the 4. Normal rounding, any digit of 5 or higher rounds up, and a 4 or lower rounds down. There's also the dot here, which is truncation mode. You just round everything down. And then we got the exclamation. According to the manual, this does statistical rounding. This is something I never heard of. It was also called banker's rounding. Would you mind a brief digression about rounding? When I was a boy, they taught me rounding. If the digit is 4 or less, you round down. If it's 5 or more, you round up. But I can remember, even as a young lad, being a little dissatisfied with rounding a 5 up. Because what about like 1.5? Rounding is supposed to give us the closest whole number, and your choices are 1 or 2, but those are equally close. So if you're doing this a lot and you round 0.5 up every time, if you're doing it over and over, doesn't that introduce some kind of upwards bias in your numbers? And the answer is yes. And on a machine like this, it could possibly matter, because the fixed precision modes are going to round the answer every time. Let's say I'm adding 1,000 numbers together on a machine like this. If you round 5s up every time, it really might inflate my result a little bit. From a mathematical point of view, I would say the best way to handle this is to round 0.5 either up or down at random. This would smooth out the bias. But of course, accountants aren't going to go for that. They always want their stuff to be verifiable and repeatable, so making random choices isn't going to fly. The solution they came up with is statistical rounding. You round like normal, except 0.5 always rounds towards the closest even number. So 1.5 will round up to 2 because 2 is even, but 4.5 will round down to 4 because 4 is even. This is weird, but it really does remove the upwards bias of traditional rounding in exchange for a weirder bias where your final rounded figures are more likely to be even than odd. But I guess for accountants, this is usually better than a uniform upwards bias. I don't know. Overall, I'd say it really does do a good job of mimicking 90s era electric adding machines. To me, those machines are strange and unintuitive, and so is this thing. But we're not trying to improve anything here, it's just copying the other thing, weirdness and all. It's a simple little program, sits there on the side of your screen, and it just does what you want. But I still can't shake my first impressions. Why don't you people just use a spreadsheet? Look, I even got one right here. It's a classic. But they still use this dumb thing. I know, people are gonna work the way they want to work. And this still happens today. I do shed a little tear every time I see somebody using a handheld calculator while sitting in front of a computer. I mean, you're already sitting in front of a machine that's 1,000,000 times more capable. Sometimes I wonder what it would be like to go back in time and talk to somebody about computers. I'd say, computers changed the world, man. They'd say, okay, but what does it do? And I could list out a bunch of stuff that a computer does, but at some point I had to say, well, like, a computer doesn't just do one thing. It can do anything. This was always the core idea, even all the way back to Turing. It's a universal machine, a machine without any specific purpose. Its job is to simulate any procedure that you can imagine. It's a simulation machine for anything you can dream of. This gentleman right here, his problem is a failure to dream. And it breaks my heart to say it, but sometimes this gentleman is me. And in the quiet of my soul, I hear the call. Throw away that stupid calculator and start dreaming. And so I dream. I dream that you would give me back my stupid calculator.